And we're back with another wonderful problem. Let's sort it out together. Acceleration on incline. Here we have a block on an incline. We have to consider friction, and we're thinking about the block as it is sliding down. So that means we're considering kinetic friction rather than static. So let's start by finding the force of friction. That depends on the normal force. And if we were to do our free body diagram for this, then we realize we have four forces here. Force gravity perpendicular and force normal are balanced. Force gravity parallel and force of kinetic friction opposing that. So that will produce the acceleration down the ramp. Force normal is going to be equal to force gravity perpendicular, so mg cosine theta. Force gravity parallel, mg sine theta. And then our expression for kinetic friction would be mu sub k times the normal force. So plug in for the normal force based on that component of gravity. Then the net force along the ramp is shown here. We know it's the combination of these two forces. Let's say down the ramp is positive. That leads us to set these positive and negative signs. Plug in for each of these. Continue to rearrange and divide both sides by m. Then go ahead and factor out that m and g. You'll notice that m cancels on top and bottom. And then our expression will simplify to this. So this gives us the acceleration down the ramp. We know that the net force comes from the parallel component of gravity and the friction force, and then we divided by the mass and we found that it canceled. So that's an expression for our acceleration.